students, how are you? I think it's fine. And I think all of you checked my previous videos. That means my classes of the atomic structure. I think all of you checked that all the videos, and I think all of you completed your home task. That means what problems we discussed, what questions were there. I think all of you solved that questions and the problems. Today we will discuss about the another chapter. The chapter is the periodic table. You know, myself, Tanmoy Datto, Assistant Professor, Department of Chemistry, JS College of Engineering, Kolani. Welcome you in my first lecture of periodic table. Periodic table that is included in the module 1 as a second chapter, and chemistry is included in BTech first year course. The code for chemistry for odd semester is CH101 and the code for even semester that is CH201. Today we will discuss about the history and the trends, that means the structure or the different types of properties of the elements which exist in the periodic table and different kinds of trends also. So without further delay, let's start the class. Do you know why periodic table is required? That means why such kind of arrangement of the elements that was required in the past days? That means there something, that's why we have to arrange all the elements in a particular way. There are so many elements present in our earth. So if there is no such kind of table or arrangement present, then it is very much difficult to keep in mind the properties of individual elements. So that's why periodic table is very much important. In the periodic table, we can understand at a glance that what will be the properties of the individual elements by checking individual groups. That means periodic table is a proper sequence of the elements by which we can understand that there may be some kinds of similarity of the properties. And that's why the individual property of the elements, if we forget, we can understand, we can recollect by checking the periodic table. So that's why from the past times that there is an effort to make a arrangement of the elements in such a manner that we can arrange all the elements in a particular way. The year of 1700, and at that time there was only 30 elements were available or discovered. Not available at that time, available, that was available from the first time, no problem, but at that time only 30 elements were discovered at that time. Then in the year of 1800, at the time the number of element increased to the 60. Now think that the 60 elements, there are different kinds of elements are present with different properties, different types of phenomena are there. So it was not possible to keep in mind the properties of individual elements. Then scientists tried to develop such kind of arrangement by which the properties of the elements will be more easier to keep in mind. Then in that category, in that field, the scientist, I think you understand who is the scientist actually here. The name of the scientist, he was the Debonnier. Okay, so in the early 1800, at that year, early 1800, Debonnier first tried to arrange the elements by that way. At least we can understand the similarity of the properties, and Debonnier first tried that there may be a set of the three elements, okay, a set of the three elements by which the average atomic weight of the first and third element will be equal with the middle element. If you check the example here, that here it is the chlorine, you know, chlorine 35, and here it is the bromine 79, and here it is the iodine approximately 1 to 6. Now just if you check the example that what Devonier have done, that the if there is a set of the chlorine, bromine and iodine, then easily we can understand the atomic weight of the bromine. That atomic weight of the bromine, that will be average of the weight of the chlorine and iodine. That means the atomic weight of chlorine plus atomic weight of iodine divided by 2 will be equal to atomic weight of bromine. There are so many another sets also, like here that sets are called actually triads. That's why it is the 3 elements. That's why that is called actually triad. So in the set of the elements, there are so many examples are there. So in that triad group, actually look here, this is the most common group. I think you have checked also when you check in the books also. That is the most common example, that lithium, sodium and potassium, because that's the most simple or most easily we can calculate that 7 plus 39, the average will be 23, and it is the main principle of the Devonier law of triad. Okay, so that is the most common example, and what I told you already, the chlorine, bromine and iodine, that is also the another example. So what happened in that way? Devonier tried to make such kinds of sets by which the properties, the main target. What is the main target of the periodic table? The main target of the developing the periodic table. The main target is that we have to arrange a set or a group or a table or whatever, by which the individual properties of the elements will be more or less similar. That was done by the Devonier first time, like lithium, sodium and potassium. Lithium, sodium and potassium, that 3 elements, they are almost similar type of properties. And also chlorine, bromine and iodine, that 3 elements also have the similar types of property. So that's why first of all Devonier established such kind of arrangement by which we got the point of the concept of the arranging the elements individually. Then the next scientist came to the field, and the next scientist was Newland. Okay, so why Newland came to the field? Because that triad, that means the set of the 3 elements, that was not possible when we move to the higher atomic mass or higher atomic weight. So Devonier's theory actually was unsuccessful to establish such kind of triads for the higher elements. So that's why that theory failed in that way. Then in the year of 1865, at that time the next scientist Newland came to the field, and Newland tried to develop another way by which it is possible to establish the sequence of the elements with the similar type of properties, and that is called actually octaves. Why it is called octaves? Actually, Newland, what he has done actually, Newland established the arrangement of the elements that with respect to the first element, if we move to the 8th element, okay, that means after 7th element, 8th element, there will be a similarity of the elements. Okay, so if you look here, that it is the most common example, that here if you start from the hydrogen, there will be similarity with the fluorine. If we consider the another example also, like starting from lithium, with respect to lithium, look here, with respect to lithium here, sodium is the 8th element. That means after 7th element, sodium comes. That's why we can understand that there will be similarity after 7th element, that 8th element, there will be a similarity of the elements. Okay, but what happened after some time, that the similarity in the chemical properties or whatever, that was not possible when we move to the same way the higher elements. That means that the similarity of the first element with respect to first element to eighth element, that was not possible, and that's why again that Newland's octave theory, that was not possible or not fruitful to arrange all the elements in the same way or a same concept. Okay, so if Newland's octave theory that was failed, then next scientist and most famous scientist, actually all of us we know very well the name of the scientist, he was the one of the Russian chemist, and the name of the scientist was Mendeleev. Okay, so first time Mendeleev was able to give a proper table by which the elements were possible to accommodate. Okay, and for that purpose Mendeleev, what happened, Mendeleev proposed that the properties, the chemical and the physical properties, that depends on the atomic mass of the elements. That means to make the periodic table, Mendeleev totally depends on the atomic mass of the elements. Okay, so at that time 63 elements were known at that time. Previously it was the 60 in the year of 1800. So at the time of Mendeleev it was the 63 elements were known at that time. So that 63 elements were possible to accommodate by the Mendeleev. So what was the Mendeleev's periodic law? That is very important for you also. That properties of the elements are a periodic function of their atomic mass. Okay, so keep in mind there at that time for making the periodic table we had to depend on the atomic mass. Okay, so according to the atomic mass, Mendeleev developed the periodic table, and this is most important that this is actually the first time Mendeleev's periodic chart. Okay, so the official version of the periodic chart that looks like almost like this picture. And another important thing is that just notice it is in German. Okay, even though Mendeleev was the Russian scientist, okay, Russian chemist, but the chart is in German. Okay, so it is actually modern version of the Mendeleev's periodic table. Look here, though at that time when Mendeleev developed the periodic table, there was no concept of the inert gas, so that's why Mendeleev's periodic table only, that was from starting from here from 1 to group 7. Okay, so starting from group 1 to group 7, though in the group 7 there are 3 elements are present. Okay, but in the group 1 there is only hydrogen. Okay, and another thing, look here, the lithium, sodium, potassium, that triads, that what was developed by the Devonier, that was also present in the Mendeleev's periodic table. That's the similar pattern actually. And look here, another thing is that what each and every group. So if you follow the group according to the Mendeleev's periodic table, there are similar kinds of properties available for each and every group, and that sequence was made by Mendeleev according to the increasing atomic mass. That means starting from the lithium, if you start from the lithium, so here lithium, then beryllium, boron, carbon, that all are according to the increasing mass of the individual elements. Okay, not only that, there is another beautiful or fruitful side of the Rutherford's model. Look here, so just look that area. Okay, look that portion, that is in another color. Why that is in another color, do you know? The color indicates that at that time when Mendeleev developed the periodic table, at that time that two elements were not discovered. So brilliantly Mendeleev just made a vacant space, okay, in that area, and he gave the name of the elements as Eka boron and Eka aluminium, and further that Eka boron was discovered further, and it was named as the scandium, and Eka aluminium, that was discovered further, which was named as gallium. Not only that, there is another silicon. Okay, so that place was also vacant in the Mendeleev's periodic table, and further later it was discovered, and it was the Mendeleev gave the name of the element was Eka silicon, and then further when it was discovered, it was named as the germanium. So that brilliantly Mendeleev made that kind of vacant place which was successfully filled by later by when the element was discovered. That is the another beautiful side of the Mendeleev's periodic table. So not only that, Mendeleev's periodic table, first of all, we got the first information about the similarity of the elements by placing them in a particular group. Okay, so but there some kinds of problems also there. Okay, so first of all, I can give you one example of that problems. Okay, so if you look here, just concentrate here. That if we consider the cobalt, okay, and the nickel, just concentrate here. What you are seeing, what is the atomic mass of the cobalt? That is 58.9, and what is the atomic mass of nickel? That is 58.7. Now think, what is the principle of the Mendeleev's periodic table? That the periodic properties which will be what was the principle? Look here, that the properties of the elements are a periodic function of their atomic mass. That means we have to follow increasing order of atomic mass. That was the principle of the Mendeleev's, but that was not followed exactly. So look here it is not followed by the Mendeleev. That cobalt, that should be after nickel, because the atomic mass of the cobalt, that 58.9, but it was placed before nickel, whereas the atomic weight of the nickel, that is the 58.7. So that is the first drawback. There are that kinds of drawbacks also present in another case. I am giving you the one example for understanding purpose. Another drawback of the Mendeleev's, or limitations of the Mendeleev's periodic table, better its limitations. You know that isotopes, if we consider the isotopes, all of you know very well that isotopes have the different atomic masses, isn't it? So if the isotopes have the different atomic masses, then what happens? Then it is expected that they will not place at the same area or at the same place. That means suppose carbon has the two isotopes, so we can't place the two isotopes at the same place, isn't it? But in the Mendeleev periodic table, there is no extra place for the isotopes also. Okay, so that is the major drawback of the another drawback of the Mendeleev's periodic table. Next limitation is that if you think that according to Mendeleev's periodic table, what Mendeleev told that same types or similar types of properties of the element, which elements have the similar types of property, they are placed in the same group, okay, or same column. But look here, all of us, we are very well known about that fact that platinum and silver, that platinum and silver both have the similar types of properties. But look, what is the position of the silver and the platinum? So they are not in the same column or same group. So that means it should be in the same column or same group, but it was not happened by the Mendeleev. So there are so many fruitful sides, but we can't ignore the limitations of the Mendeleev's periodic table. So that's why the next scientist came to the field. Who was the next scientist? The next scientist was, look here, that he was the Moseley. All of you know very well that Moseley came to the field, and then what happened? And it is the picture of the scientist, and in the year of 1930, okay, he was just 25 years old English physicist, okay. So the full name is the Henry Moseley, okay. So then Moseley showed that the ordering of X-ray spectral lines was dependent upon ordering the nuclear charge. Okay, so then Moseley thought that there, if it is possible to change that the theory like atomic mass to the atomic number, then it is possible to explain so many parameters or so many factors or so many problems or limitations which exist in the Mendeleev's periodic table. So what he did, he just changed the law. Change the law means he changed the concept from atomic mass to atomic number. So further, when he developed the periodic table that is taken as the modern periodic table, whatever, then further it was also modified, but it is the modification of Mendeleev's periodic table. Then he showed that all the elements, their periodic properties are according to their atomic number, not atomic mass. So you have to, students, you have to keep in mind very carefully that up to Mendeleev's periodic table, the periodic properties, it was taken according to their atomic mass. But when Moseley came to the field, he established a different kind of periodic table which was dependent on the atomic number, not on the atomic mass. And this is the Moseley periodic table, though further it was again modified in that way. So this is the almost modern periodic table after modification. And in this modern periodic table, look here that first of all it is according to the atomic number. When it is developed according to the atomic number, how nicely it was explained. Just think about that all the problem was solved. All the problems means that isotopes, you know, all the isotopes have the same atomic number, isn't it? So that means it is expected that all the isotopes should be placed in one place. If you take the example of carbon, okay, so carbon, all the isotopes have the same atomic number, so there is no question of giving the different place for the each and every isotope. Okay, so problem solved. Second problem, what was the problem regarding the what sequence was not maintained properly? Here there is not such kind of any problem, because if you think about, if we go to the Mendeleev's periodic table, just look here, cobalt and nickel. Okay, so if we think about cobalt and nickel, it is according to atomic number. That means nickel has the higher atomic number with respect to cobalt. So there is no problem when we are thinking about the according to the atomic number. So that problem was also solved. Another problem was that regarding what I told you, that different kinds of metals have different properties. That was also solved by when we are developing the that kind of modern periodic table. Now come to the fact that what are the factors which we have to know regarding the modern periodic table. First of all, look here. There are two things which you have to keep in mind, that in modern periodic table there are two terms. One term is that row. Okay, so these are called actually rows. Okay, 1 to 7. So that means in modern periodic table there are 7 rows are there. Okay, and 1 to 18. Okay, so 1 to 18, these 1 to 18 are called groups. Okay, so that you have to keep in mind. So 18 groups are present in the modern periodic table, but 7 rows are present in the modern periodic table. So that 1 to 18 groups are sometimes called also like 1A, 1B or 2B, like that. Or 18 groups which was not present in the Mendeleev's periodic table, 18 groups, that is taken as the 0th group, because that elements are inert, because in that group that inert gases are present. They are normally generally they are not taking part in the reaction, so that's why they are taken as the 18th group or inert group or the 0th group. Okay, so but other than this there are actually 4 different blocks are there depending on the electronic configuration. So what is the electronic configuration, I will discuss again, but at that moment, just from the concept of atomic structure, all of you know very well that there are actually 4 subshells are there, S, P, D, F. So there's a chance that for few elements the last electron should occupy the S. For few elements, last electron should occupy the P, D, and F. So depending on that fact, actually there are 4 blocks. So this 1 and 2, this block is called, it is the S block. So in the right hand side, look here, that right hand side, all the elements here highlighted parts, so all the elements, that block is called P block, because the last electron of that elements enter into the P subcell. So depending on that point, that all the elements are in the category of P block. So now in the middle part, that is the most important part. In the middle part, that elements are called D block element. Okay, there is another name also, they are also called transition element. Why it is called transition element? Because here it is actually looks like it is a bridge. Okay, isn't it? It is a bridge between the S block elements and P block elements. So that's a transition between the S and P block elements. So that's why it is called actually transition elements or D block elements. D block elements, why? Because that last electron enter into the D subcell, that's why it is called the D block elements. And the lower one, and here the all the elements, the last electron enters in the F subcell, that's why it is called the F block elements. Okay, so this is the category depending on the different types of blocks of the last electron enters in which subcell. There is another thing also, then another name, particular name of the each different types of groups are also present here, which you have to keep in mind, because that name of the groups are very, very important. So first group, that is the one group, just look here, that group is called it is the alkali metals. Okay, that group is called actually alkali metals. And second group, that group is called alkaline earth metals. Okay, that is very, very important also. And here the most important group, that is the 17 group 17. This group is called actually halogens. I think many of you know about that fact, about this fact. So that fluorine, chlorine, bromine, iodine, astatine, that group is called, it is the halogen group. Okay, and next one, that oxygen, that group 16, oxygen, sulfur, etc., that elements are included in the category of chalcogen. Okay, and what I told you, that 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 the 0th group or 18th group, that is the group of inert gas or inert elements, because they are not take part in the reaction. Okay, now here in the transition element, there is another thing which you have to keep in mind. There are 2 places which is here, which are here star marks. Okay, so first one is the lanthanides. So lanthanides, that all the elements are in the same place actually, that's why here it is the star mark. Okay, so that all the elements of cerium to lutetium, that all the elements are in the same position, that's why it is called Lanthanide series. Okay, and another is the Actinide series, that means here all the elements are starting from TH to Lr, that all the elements are in the same place, so that is called actually Actinide series. Okay, so that all the things you have to keep in mind. Another thing, very important thing which you have to keep in mind, that left hand side normally they are metals, and right hand side normally they are non-metals. I can tell you that how you can get that information, but you have to keep in mind that all the things in this way. And this is the rough structure or rough picture by which you can keep in mind the blocks, each and every blocks S, P, D, F. Okay, so this you can I think this will help you to keep in mind the each and every blocks. Okay, so classification of the elements, what I just told you that there are 3 types of elements, mainly metals, non-metals, and metalloids. Okay, so if you think about the metals, the left hand side, okay, group 1, 2, like that, they are located at the left side of the tables. Okay, located at the left side of the tables, they are called actually metals. Okay, there are some properties of the metals. Metals generally form the cations. They have a tendency to lose the electrons, or they can produce the plus charge, and they are shiny, they are hard, they are good conductors of heat and electricity, and they're ductile, etc., etc. That mostly are solid except mercury. So that all the things you have to keep in mind for the metals. Okay. So another things, non-metals, obviously they are right side of the periodic table, and they generally they wants to gain, there's a tendency to gain the electrons, so that's why they can form the anion. If any neutral thing, a neutral atom gain the electrons, obviously it will produce the anion. So obviously that are in the category of the tendency to form the anions. They are the brittle solid or maybe gases. Sometimes they are poor conductors of heat and the electricity also. That you have to keep in mind, that non-metals are generally poor conductors. Okay, and then another category, they have the both the nature of the metals and non-metals. Okay, so that are called actually metalloids. And look here carefully. So this left side almost they are metal, and right side they are almost non-metals. But that sequence, or this sequence is the line of the metalloids. Okay, so this you have to keep in mind, that this sequence is the maximum metalloids present according to this sequence. Okay, so then this is the categories which I already discussed with you. You can take a snaps. This is the overall classification or the categories of the elements. Okay, and then we'll move to the questions. Okay, so before going to the questions, I can give you one thing that already I told you in my each and every class, that just make a note, make your note. Okay, what I am discussing with you, just write down all that things in your copy. Then try to solve maximum numbers of questions. What question I am giving to you here, that these questions are the sample questions, but you have to solve more and more questions for the exam purpose. Okay, so the questions are here. The first question which you have to solve, and the answer of the questions I will discuss in my next class. Okay, so just take a snapshot of that questions. That first question is the what are the drawbacks of the Mandala's periodic table? I already discussed with you, but you have to write down in your way. Second question, chalcogens and halogens exist in which group? Third question, how many blocks are present in periodic table, and depending on which factor you have to explain. Okay, and the fourth question, what are the names of Eka boron, Eka aluminium, and Eka silicon? That also I discussed during my class. Okay, so this is the overall discussion for this class, and that's all for today. And just you have to prepare all the topics which I discussed today, otherwise it will be not possible to understand the facts which I will discuss in the next class. So up to that time, take care, goodbye.